Hello students, I am Jaspreet Kaur and today we are going to continue with the chapter that is the redox reactions, and we are going to study about the different types of the reactions that fall under the category of redox reactions. So we have three different categories of the reactions that could be the combination, decomposition or disproportion reactions. We will study about them briefly. So starting with the very first one, that is the combination reactions. Combination reactions, as the name says, combining of the elements, or it could be combining of the compounds. Leading to the formation of some new product or the new compound. That is said to be combination reactions. Whenever there are the two elements or the two compounds combining together under certain set of the conditions of temperature and the pressure or the other conditions, they lead to the formation of a new compound, and such kind of the reactions, they are said to be combination reactions. So very first example, this is a basic, a generalized form. There is a element A, element B. When they are combining together, they react together to give a product which is C, a new product, or we can say that a new compound. Moving ahead, I have written over here three examples. First of all, addition of oxygen to carbon. We read in the very first session that when there is an addition of oxygen to any compound, any element, it leads to the formation of reaction, that is an oxidation reaction. So I could see here that oxygen is present in its elemental form. So if it is present in its uncombined state, I will give its oxidation state as 0, similar to the carbon, because it is present in its elemental form. Elemental form, that is the uncombined form, it carries or bears the oxidation number, that is 0. On reaction, we found it out that oxygen, we know that oxygen is always present in the -2 state except in the superoxides and the peroxides. If I have to find here the oxidation state of carbon, can I find it out? Because I told you in the last session as well. So I would revise it for you people, taking it as the X plus oxidation state of oxygen is -2, multiplying it with 2 and equivalent to 0. Since it is a neutral compound, I have X minus 4 is equivalent to 0, X is equal to +4. So I got to know that carbon is present in the +2 form, oxygen is present in -2 form. Since there is an increase in the oxidation number, whenever there is the increase in the oxidation number, that particular reaction is said to be oxidation. And whenever there is a decrease in the oxidation number, that particular reaction is said to be reduction. So here, it's very clear, carbon is getting oxidized and oxygen is getting reduced. So this is, since reduction and the oxidation is occurring in the same reaction, we could say that this is the redox reaction. Similarly, magnesium again in the 0, nitrogen in the elemental state 0. Here magnesium in the +2 state, because we studied that it is equivalent to the ions they are forming. So magnesium is having the valency +2. Here also the oxidation state is present equivalent to the +2, and nitrogen it could be -3. Fine, moving ahead, methane, oxygen, formation of carbon dioxide and water. If I have to figure it out, what is the particularly the oxidation state of carbon over here, it could be +4, hydrogen in the +1 state, oxygen in the 0, carbon again we have found it over here +4 and oxygen in the -2, hydrogen in the +1, oxygen in the -2 state. So some of the elements getting oxidized, the another one getting reduced over here. I hope this is clear. What is the combination reactions? Different elements, they are combining together, they are leading to the formation of the new compound. Now when they were reacting together, they were having a different oxidation states, and when they are forming a new product, in that particular compound they are having a different oxidation state. This is the combination reactions in the redox reactions. Very important thing, whenever there is a combustion reaction that is involving the addition of what? In the combustion reaction, we always have addition of oxygen. In such kind of the reactions, we could see that all the combustion reactions, they are redox in the nature. Fine. So combustion reactions involving addition of oxygen, they are redox reactions. So that was about the combination reaction. we will move ahead with the another one, which is the decomposition reaction. So decomposition, we have heard this word many times. Decompose means break down, splitting up of one to the another. So decomposition reaction, as the name says, it is the breaking down of the given compound to the another elements, or it could be another compound. We will study about it. So here are the reactions of the decomposition kind of the reactions. We have here decomposition of the water molecules. It gets split up into the hydrogen and the oxygen. Let's talk about their oxidation numbers. Hydrogen in the +1 state, oxygen in the -2, 0 and 0. Fine, turning back to their elemental form. Then sodium hydride +1 and hydride in the -1 form, 0 and 0, again in their elemental state. Okay, so here we have potassium chlorate decomposing into the potassium chloride and the oxygen. So here it could be potassium in the +1, oxygen in the -2. We can find out by using our method of finding the oxidation number. So let's find it out. Potassium, that is the +1, fine. Chlorine, it be X, and oxygen, that is the -2, but number of element 3. So we are multiplying it with the 3, equivalent to 0. This implies 1 plus x minus 6 is equal to 0. And x minus 5 is equal to the 0, so x is equal to +5. So can I write here +5? Yes. Moving ahead, potassium again +1 and chlorine here -1, oxygen in the 0. Since there is a variation, I would say that in the oxidation states, in the oxidation number, when they are splitting up into the different compounds, either the elements or the another compounds, there is a change in the oxidation state. This reaction is said to be decomposition. Decompose itself means something which is breaking down. Clear? Now there is a one reaction, fine, we have calcium carbonate decomposing into the calcium oxide plus carbon dioxide. Fine. So let's check out their oxidation state. Calcium in the +2 oxidation state. Carbon could be in the +4 oxidation state and -2. Calcium oxide +2 and again -2. Carbon dioxide +4 and -2. Let's check it out here. In the case of calcium, the oxidation state before the reaction was +2, after +2. So +2 and +2. This is before and this is after. Fine. Moving with the carbon, +4 and +4. No change. Oxygen -2 and -2. Do you think there is any kind of oxidation and reduction that has taken place over here? Another reaction I would tell you, methane was there reacting with the oxygen, giving us carbon dioxide and water molecule. Fine. So here we had the carbon in the +4 state, hydrogen in the +1 state. Clear? Oxygen 0, carbon again in the +4 and -2. Again here we have this hydrogen in the -1 and oxygen in the +2. Clear? So let's check it out, the oxidation states, the changes that has been taking place. What we figured out that here the change in the oxidation state is same, the sum is same. Clear? And over here there was no change. It means, this implies that in few of the decomposition reactions, they are not the redox reactions. Redox means there is a change in the oxidation states, there is a change in the gain or the loss of the electrons. Since we find it out that there is no change, there is no gain, there is no loss, so we can say that this reaction, which is decomposition in itself, it is not the redox reaction. So we could say that not all the decomposition reactions, they are the decomposition reactions. So I hope this is clear about the decomposition reactions. What are they? What are the kind of the examples? How can we tell that this particular reaction is belonging to the category of the decomposition reactions? We always need to check the oxidation state. Here we have the third category of the reactions, that is the displacement reactions. The name says displacement. That means one element must be there to displace the another element in a given compound. Fine. That is why the reaction is named as the displacement reaction. Please have a look over here. We have this x plus y combining to give the xz plus the y. It could be, sorry, yz. So we have this particular compound which is yz, and here is the x. So there is a new formation of the compound which is the xz, and here it is the y. We could say that here in this compound x has displaced y, and hence it has led to the reaction which is known as the displacement reactions. Now there are two kinds of the displacement reactions. First of all, the metal displacement. The another category is the non-metal displacement. Talking about the metal displacement, name says the displacement of metal could be there. We have already done this particular reaction in the previous video where we were there to study about the competitive electron transfer reactions, where we find that zinc can easily lose the electrons to copper and copper can lead to the silver. Where we studied about a electrochemical series, that the element which is at the topmost in the series that can easily lose the electrons, they are the good reducing agents, and those which are not capable of easily losing the electrons, they are the least reducing agent, or they are the poor reducing agents. Fine. So here we have this example, copper sulfate reacting with the zinc, giving us zinc sulfate and the copper. So copper plus 2. If we talk about oxygen, minus 2, and what about sulfur? It could be plus 2, we have x, and minus 8, and x it comes to be plus 6 over here. So we have sulfur which is equivalent to the plus 6, zinc in the 0 state, again zinc in the plus 2 state, this one in the minus 2 and plus 6, and here we have 0, the elemental form. In that previous video also we learned this thing, that zinc was there to lose the electrons to copper. Clear? Then moving ahead, so we could say that in this particular reaction, zinc it has displaced copper. We could see that the changes here, it was copper sulfate, and here we have the zinc sulfate. We can clearly say that zinc it lost the electrons to copper, hence it displaced the copper from that particular solution. Moving ahead, we have the chromium oxide. Here the chromium oxide reacting with the aluminium which was present in its elemental state. So here if it is minus 2, then 2x minus 6 is equivalent to, so it is in the plus 3 state. Again aluminium in the plus 3 state, oxygen in the minus 2 state, and chromium being a metal in the 0 state or the neutral state. So here we have that chromium it was displaced by aluminium, because aluminium it lost the electrons. We check here plus 3, that oxidation number has increased. Increment in the oxidation number, what does that mean? Oxidation has taken place. So we could say over here that there is a displacement of the chromium by aluminium. Hence there is a displacement of one metal by the another metal. These reactions are said to be the metal displacement reactions, that whenever the reactions are occurring, the redox reactions are occurring when the one metal is being displaced by the another metal which is highly reactive, because it is only the highly reactive metal that can easily displace the another metal. That leads to the formation of the reactions which are metal displacement reactions. Please keep it in mind that one which is the good reducing agent, it has the higher capability of losing the electrons. So, or the one which easily loses the electron is a good reducing agent. Fine. So, this was about the metal displacement. So, in the category of the displacement reactions, we have the second type, which is the non-metal displacement reactions, displacement of any non-metal. First of all, there are two categories further, the displacement of hydrogen, dihydrogen we could say that from the reactions, and secondly the rarely occurring reactions which are which involve the displacement of oxygen. Fine. So the very first reactions, the first two reactions I would say, sodium and calcium, they occurring with the water molecule. So when sodium react with the water molecule, sodium and calcium, they are very reactive metals. Being the reactive metals, they are even capable of reacting with the cold water. So here we have the cold water, the condition is cold water, and they are leading to the formation of the hydroxides and liberation of the dihydrogen. Clear? So the most reactive metals like sodium, potassium, calcium, they react with the water under the cold conditions, with the cold water, leading to the formation of the hydrogen and their hydroxides. Let's talk about their oxidation states. Sodium in the elemental state 0, hydrogen +1, oxygen -2. In the sodium hydroxide, it will be in the +1 state, oxygen in the -2, hydrogen in the +1. And here elemental hydrogen in the 0 form. Since there is again the oxidation and the reduction that is occurring place, I would say that this non-metal displacement reaction is the redox reaction. Clear? Moving to the another example, I hope this is clear. The conditions are cold water is being used over here. Moving to the another set of the elements from sodium, calcium to the another, moving to the another period, I would say that we have the elements like magnesium, we have the elements like zinc that are actually not capable of reacting with the hydrogen with the water molecules under the cold conditions. They require a steam form, that is, when the magnesium is reacting in a steam form with water molecules, it gives us the magnesium hydroxide and the hydrogen. So again the elemental hydrogen. I would check it out over here. You need to check it out over here. In fact, that there is a change in the oxidation states. Please find it out. What is the change in the oxidation states over here, and how does it represents the example of a redox reaction? Clear? Moving ahead to the less active metals, zinc and iron. Now these neither react with the steam form of the water nor with the cold water. So they are capable of displacing the hydrogen from the acids. For example, zinc, it reacts with the HCl giving us zinc chloride and the dihydrogen. So I would say that zinc in the elemental state, hydrogen +1, chlorine -1, zinc again +2, fine. Chlorine in the -1 state, hydrogen in the this particular form. So in the elemental form, I would say that this is the typical example of the known metal displacement reactions, but for the metals that are less reactive as compared to sodium, magnesium, calcium, and they are capable of displacing the hydrogen only when the hydrogen is available in the acidic form. Similar is the example with the iron. So I hope it is clear. The reaction conditions are clear to you people, that when there is a non-metal displacement, what kind of conditions are suitable. Very, very important from the exam point of view. Usually these questions are asked, their conditions are being asked. So I hope it is very clear to you people. Fine. Moving ahead, we have the another category, which is the displacement of the oxygen. Now what do you think? Which element can displace the oxygen? Is it iron? Is it, we could say that it is the fluorine, it is the chlorine, is it the iodine? Which element is capable of, displacing the oxygen from the reactions? We will just study about it. Moving ahead with the another category that I told you, that is where the oxygen is being displaced. Though these reactions rarely occur, but there are few reactions that are very important to discuss. The very first one is the reaction in which fluorine, it is actually displacing the oxygen. Fluorine being reacting as the most reactive metal, displacing oxygen from the water molecules, leading to the formation of hydrogen fluoride and elemental oxygen. Let's talk about its oxidation number. +1, that is -2, 0, +1, -1 and the 0. So we could see that there is a increase in the oxidation number of few elements, decrease of the another, hence the reaction is the redox in the nature. Secondly, there is a very important thing that we usually don't carry out the reactions of water or reactions of fluorine, chlorine or the bromine in this water molecules. We don't carry out in the aqueous solutions. The reason being, they can easily displace that oxygen molecule. Hence, this reaction is something which is not acceptable in the industrial use. So it's always avoided, so that the fluorine, chlorine and bromine reactions, they are not carried out in the aqueous form. Secondly, we have this particular reactions where chlorine is displacing the bromine as well as iodine. So something which is very important, we know that fluorine is the most reactive element, non-metal. Chlorine, then bromine and then iodine. Now this fluorine is capable of displacing all the elements. It's capable of displacing chlorine, bromine and iodine. On the other hand, chlorine, it cannot displace fluorine because it is less reactive as compared to fluorine, but it can displace bromine and the iodine. Similarly, bromine can displace iodine. Iodine cannot displace any of these non-metals over here. Now, this particular reactions in which chlorine is replacing or displacing, we could say that bromine and the iodine, these are said to be the layers test. There is a reason by this particular reactions they are said to be the layers test. For example, if I have the chlorine over here, I would write Cl2, Br negative, fine, Cl negative plus Br2. -1 form, 0, -1 form and 0 form. Now since we know that it gives us the Cl negative ion, clear? Okay, so we were discussing about the layers test. The reaction is said to be the layer test. The reason being, we see that the chlorine, it's easily able to displace bromine and the iodine, and it is giving us the elemental bromine, elemental iodine. Here in the second reaction we have chlorine plus iodine, I negative, Cl negative, fine, and I2. 0, -1, again -1 over here and 0. Now the layer test, it is said to be layer test because in the laboratory this reaction is very important. When we have to find out which ions are present over there or which element is non-metal is there. In that case, when we have to do the test for the bromine and iodine, this is important since bromine and iodine, they have their own colors, different colors, and this reactions involves the release of the elemental bromine and elemental iodine, means they will be having their own colors in here, and it is very easy to identify when the elements, they are liberating their own colors and they are present in the solution form or they are present in the gaseous form. So this reactions, I would say that it involves the various kind of the non-metals displacement, hence the reaction is named as the non-metal displacement reaction. Now moving ahead, it's not easy as well to convert this F negative to the fluorine with these particular reactions. It cannot be done, but electrolytically we can just convert F negative ions to the fluorine. What's the reason? The very first thing, fluorine is the strongest oxidizing agent. That means it is the one which is having the higher tendency to gain the electrons. Hence, it is acting as the strongest oxidizing agent. Clear? Now, this particular fluorine ions, it cannot be converted to the elemental fluorine because elemental fluorine means the gain of electrons. Since this is the element which is most reactive, it always loves to have the more and more electrons. It is not possible for them. It is not digestible for fluorine ions to get more electrons to form the fluorine, elemental fluorine. Fine. So this is the element, I would say, that which is acting as the highest oxidation agent, the oxidizing agent. So that was about the non-metal displacement reactions. Further, we will learn about the disproportionation reactions. The last reaction we are left with, that is the disproportionation reaction. In this reaction, the particular element, it disproportionates into the different oxidation states. For example, we could say that at the same time the element is getting oxidized, at the same time it's getting reduced. It means the element will be exhibiting the variable oxidation states or the oxidation numbers. Fine. So let's have a look at the example, but this thing is happening simultaneously. Hydrogen peroxide, hydrogen being present in the -1 state, +1, and oxygen in the -2. Here it is present in the +1 and here -2. Let's check it over here. That is the +2 -2x is equivalent to the 0. So I would say that it is 2x is equivalent to 2. It's in the -1 state. Fine. So we have the hydrogen peroxide which is present in the this particular state. Here it is the -1 and oxygen in the 0 state we have. Clear? So oxygen is present in the form -1, -2 and the 0. Hence we could say that this reaction is the disproportionate reaction. Moving ahead, we have the another example where chlorine, it is reacting with in the basic medium, in the alkaline medium, giving us the hypochlorite ions, Cl negative and the water molecules. Now here we could see that elemental chlorine is present in the 0 form. 0 oxidation state. Here we have the hydroxide. We could say that oxygen in the -2, hydrogen in the, because it is an ion, so we will get a different oxidation state for the same. Basically, we are concerned with the chlorine over here. Looking about here, I could say that ClO negative ion, so chlorine as the X, I could take oxygen as the -2, here -1, so it is present in the +1 state, I would say that. Clear? It's clear now. Moving ahead, the -1, and here again the +1 and the -2 form. In the OH negative ion, I could say, if we have, that means equivalent to the -1, fine. Let's talk about oxygen only, oxygen as the X, and that is the +1, then X -2. So it's present in the -2, this is in the +1 form. So from here, this particular reactions, when the chlorine it's showing the disproportionate reaction, in that particular case it is used as a bleaching agent. Bleaching agent which is used to remove the stains from the clothes and turning that stains into the colorless. So this particular reaction is very important into the, I would say that in the dyeing industry, where they are dyeing the different kinds of the clothes. Manufacturing industries, where the clothes, when they are being manufactured, this particular reaction is very, very helpful. Moving ahead, the last one, fluorine reacting in the alkaline or the basic medium, giving the F negative, OF2 and water molecules. Now in this particular case, I'll check the different oxidation states of the fluorine, being in the elemental 0, here -1, OF2, because I told you in the beginning, in the very first series, in this oxygen difluoride, oxygen is present in the +2 state. If it is +2, here it is +2x. We have 0, 2x is equal to -2, x is equal to the -1 again. So I would say that here fluorine is present in -1 state. See, 0, -1, -1. But if we talk about the other one, here oxygen was in the -1, here it is in the -2 and the 0 state. Clear? In this particular reaction, we would say that in this one, where the fluorine is not converted into the plus state, it is the only non-metal which is not possible to convert it its +1 state. There is an exceptionary case, but it's very difficult to convert fluorine to its +1 state. So since it's very difficult to convert this one, it is said to be the highest oxidizing agent. It is the non-metal which cannot be oxidized, I would say that, easily. It could not be oxidized easily. So this was all about the disproportionate reactions. Here we have studied about the 4 categories of the reactions. The first one was the combination, second the decomposition, third displacement, falling into the 2 categories, metal displacement and the non-metal displacement, and finally these disproportionate reactions. I hope these reactions are clear to you people. That's all for the day. Thank you.